Welcome to Session 4, Factors, Multiples, Primes, Exponents, and Roots. Factors and multiples reveal the structure inside whole numbers. They support fraction simplification, common denominators, measurement grouping, and algebra. Exponents compress repeated multiplication, while roots reverse powers and connect arithmetic to geometry. By the end, you'll be able to do the following. List factors and classify numbers as prime or composite. Find greatest common factors and least common multiples. Write and use prime factorizations. 3 ideas organize the lesson. First, factors divide exactly. Multiples grow by repeated groups. Prime factorization exposes a number structure. Roots reverse powers and can be bounded by perfect squares. Example 1. Find the greatest common factor of 24 and 36. Their prime factorizations are 2 cubed times 3 and 2 squared times 3 squared. Keep only shared primes at their lowest powers. 2 squared times 3 is 12. Check. 12 divides both values, and no larger common factor does. Worked example 2. For the least common multiple of 8 and 12, include enough prime factors to contain both numbers. The highest required powers are 2 cubed and 1 factor of 3. Their product is 24. Check. 24 divides evenly by both 8 and 12. Worked example 3. To locate the square root of 70, compare 70 with nearby perfect squares. 8 squared is 64, and 9 squared is 81. Therefore, the square root of 70 lies between 8 and 9, a little closer to 8. Check. Squaring the two bounds reproduces 64 and 81. Watch for this common error, treating the exponent as a number to multiply by the base. Correction. An exponent counts repeated factors of the base. Use this routine. Name the target and units. Choose a relationship. Calculate with clear steps. Then estimate and verify. Expose the number's multiplicative structure. Choose the factor, multiple, exponent, or root relationship, and verify with multiplication or divisibility. For more lessons and focused practice, visit bridge2exam.com.